both even. You see here is like even, odd, odd, even, odd, odd, even. So you do that tricky. But now you see the both even power. Sine, integral of sine, and then I give you cos x dx. So how I'm gonna go for this? So this you have to know double angle of sine and cos. So now I know for effects, if somebody give me, so I'll use another pen here. If somebody give me, let's say cos double of my angle, this let me say, if I want everything else to be cos, this let me say 2 cos x minus 1. Okay, 2 cos square x. So if I had to replace this cos square x, means let me make this subject so I can make it. So I want to make this subject so I can replace. So cos square x, take this one here, it's going to become cos 2x plus 1 and then over 2 equal to cos square x. Make subjects. So I can replace this with that. Same with sine. This formula, which is cos double angle, sometimes you can write it as 1 minus 2 sine square x. So I want to replace this sine square x. So you did not replace for the previous one because these are odd number, like this is odd number, this is odd number, you cannot. But for square, yes, you can. So what I want to do, and let me add a question here. This question is very, very important. Let me say integral of sine 4x dx. Let's say this is 3. Let me say something like this, because this one also will come, this power 4. Okay, cool. I'm gonna come in do this. Let me see if the space is enough there. Yeah. Okay, cool. I can write here under a little bit. So say integral. So this is going to be 788 now. Question 88. Question 88. Very important question. So say integral sine 4 3x dx. Let's say. Okay, cool. So now I'm going to do, let me make a subject was sine of sine x. If I make subject, means this is going to come over. It's going to become sine square x 2, and this is going to be 1 minus cos double angle. Divided by 2 means divided by 2. So this is not there. So let's replace both. So meaning this is going to become integral sine square is going to be 1 minus cos double angle over 2, and then for the other one, which is cos, what is that cos? So cos equal to, cos square equal to cos double angle plus 1 over 2 dx. 2 times 2 equal to 4. So this one is going to go to the back. 1 over 4. So what I'm going to do now, man, it's crazy. Okay, let's multiply that out. So it's going to be 1 over 4. Integral, okay, 1 times 1, oh man, let's say, no, this is a difference of 2 square. If difference 2 square means it's going to be, oh no, let's say 1 minus cos square, I can say 1 plus 2x, okay, 1 plus 2x. Like other one, 1 plus what, cos double angle. So this let me say 1 minus cos square of my double angle. I can say that, acceptable dx. Then I can separate. You see what I'm saying? I can say 1 over 4 is just 1 over 4, and then I can say integral of dx, because this for 1 is like 1 dx, minus integral of cos square double angle and then dx. But this also have to do the same approach I did it, because cos square, whenever there's a square, I can do the same thing. So cos square, what's cos square? Cos square equal to that. So now look how I'm going to place it. So see, look, when you integrate 1 dx, so 1 dx is like dx, integral dx equal to x minus. So look, this is cos square. If it's cos 2x squared, means I must put 2 here. If this it was x, here it was 2x, means if this is 2, this can be 4x now. Does it make sense? Look, 2x. It was x, here it was x. It was 2x, excuse me, at first. X, 2x. So if this is 2x, this must be 4x. So then I'm going to say integral. Instead of that, it's going to be cos of 4x plus 1 over 2. See what I'm saying? dx. Okay, 2 can go back, so this is going to come here, 1 over 2. And then what we're going to do, let's hammer that one. So now we say, after that, it's going to be 1 over 4x, and then this is going to be plus 1 over 18. Now, so now we can separate this integral of cos. I can do shortcut, but I just do this for you. Plus integral of 1 dx, which is just like dx, okay? So this is going to give us 1 over 4x plus, okay, when you integrate cos of 4x means integrate that. Which is, and then we're going to write 1 over, we still have 1 over 8 here. It's going to be 1 over, differentiate this is going to give us 4. And then when you integrate cos, you get sine. But at the same angle, and then we plus. Integrate that one, you get x plus constant, or you can multiply that out, and then we finish. So this is going to be 1 over 4, x plus 1 over 32, sine of 4x plus 1 over 8, x plus c, if you want to expand. So now we're done. Let's go to question 88. So like I said, when you finish this, is going to be question number 88. So, okay, remember, no problem. This one here. I'm not supposed to raise that one because I'm going to use for this same question here. I mean the blue, whatever double angle. Okay, now let's do question number 88 here. Question 88 is easy. So sine, so I'll say this, let me say sine is power 4, right? So I'm going to say power 2, 3x, and then here I'm going to put square dx. Let's put 6 for example. Let's put 6. So if it's 6 means here I'm going to put 2, I'm going to put 2, and then here I'm going to put 3 for a reason because I know this one I can get it. You see what I'm saying? So now I go to my double angle. Double angle says I want double angle cos. Double angle, it comes from cos double angle. So if I want to replace sine, it means it's going to be 1 minus 2 sine double my angle. You see what I'm saying? Double my angle. See? But now it's not x, is 3x. You see, square, 3x, here x. So I'm going to put here 3. If this 3, this is going to be twice of this, which is going to be 6. So now I want to make subjects that, so I can come and replace. So this is going to become over, it's going to be 2 sine square 3x equal to 1 minus cos 6x divided by 2 divided by 2. So this is going to replace. So now integral, instead of writing there, I'm going to say 1 minus cos, this question is big, man. And then power 3 dx. You see what I'm saying? So now let's make 2 because 3 is going to be so big. You know, it's going to be so big. Let's make 2. So it's like power 4. Let's take 2 power 4. So this is just like how we did before. So it's going to be integral. This is going to be 4 because 2 squared equals 4. So it's 1 over 4. And then here's going to be 1 minus cos 6x and then dx. Square. This is square. So if you square that, it's going to give us, okay, let me square straight away so we can see the space, okay? Okay, so now this is going to be 1 and then this is going to be negative 2 cos 6x and then we plus cos 6x, but here there's a square because you're going to have to multiply the same thing. Okay, dx. So what we're going to do now, we can separate all of them. So see, 1 over 4, okay, integral, and this is integral of the first one, 1 dx, which is going to give us x, minus 2 integral of cos 6x dx. Now we go for the last one, plus, and this one can get it too, because I can just do straight away, because when you integrate this, it's going to give us 6 at the bottom, and then when you integrate cos, you get sine 6x. So it's going to be just sine 6x. Sine 6x. 2 over 1 is 1 over 3. Okay, now plus. So we're going to have to do the same thing here. But this is cos now. So we can now use this formula. It's cos square. So for cos square, almost the same formula, but now it's not going to be like that. So for cos, it must be 2 cos square x minus 1. You know what I'm saying? And this is 2 for cos. Double angle tricky. Everything in my head means I'm not looking at the paper, okay? So now, this one here, we know we can just replace it. Cos square 6x. Cos square, so this not x is 6x. If this it was x, it was 2x. If 6x, this must be 12x. So I want to make subject to cos square 6x at a place. So this is going to be cos. You get this from trig identity plus 1 over 2 equal to cos square 6x. So I'm going to replace cos square 6x. Means it must be integral. Instead of saying, because integral the last one. So instead of saying integral that, I'll replace this with it, which is going to be 1 of 2 is going to go at the back, 1 of 2, and then we'll write cos 12x and then plus 1 dx. And then this is going to give us 1 over 4x minus 1 over 12, 6x. Now, this is going to be 1 over 8. Now, we can separate this. Now, integral of this one, say cos, I can do straight. Let me just do straight, okay. Integral of cos 12x will be 1 over 12 and then sine 12x. Okay, now integral of this will be just x. Just x, so plus x. So this is 1 over 4x minus 1 over 12 sine 6x, and this is going to be 1 over 32. 1 over 8. 1 over 8, x over 8 plus constant c. So that's how you do. So we're done with the question 88. Now let's move down. I'm going to this one right there. Okay. Okay. I want to know this question. This is a very, very important question for later. Okay, son. for 3x, I say, okay, dx. Okay, cool. Now let's go to the next question. Okay. Okay, cool. Now, let's go. So now, we go to question number 77. Question number 77. So now, they give us, okay, so easy. Integral. What I'm going to do, I'm going to play the same tricky. Let me show you something. Okay, let's copy the question. Let's say sec power 9x, and then you got tan power 5x dx. So what we're going to do here, look, this is very important. This is very, very important, family. Okay, this is very important. Okay, now, this you have to know this. When somebody give you sine, okay, let's say sine square theta or x, because we use x for now. Okay, x plus cos square x equal to 1. If I want to get sec and tan, okay, I want to get the relationship between sec and tan. So what I'm going to do then, look, if I want to get sec, means I have to divide by cos. So divide by cos square x throughout, divide by cos square throughout, divide by cos square throughout. When you take cos and cos, you get 1 plus 1 divided by cos, you get equal, excuse me. 1 divided by cos, you get sec. Okay, now here, this is going to give us 1 plus sine divided equal to tan square. Also, this is the identity of sec. So I'm going to play with this to solve this question. Okay, I can't even write a side here. So, okay, so I know tan, let me write here. Let me use a blue pen. So I'm going to say my tan square x plus 1 equal to sec square x, because I'm going to use it for this question. Okay, and then I'm going to raise this one here, because I know how to get. So you don't have to memorize, as long as you know sine square plus cos square, and then you know how to get that. Okay, now let's go. So with this question here, look what I'm going to do. Oh, nobody tell me, but I'm going to have to think, oh, well, let me do this. Because if I can take sine and sec here, and they'll be done. Okay, look, I'm going to try the fix on this, okay? If I differentiate tan, I get sec tan. So I'm going to say in when, okay, let me do straight away, because most of you guys, you understand what is happening here. So let me do straight away. Just, okay, this let me say, take 1 sec, take 1 tan here. So it's going to be tan x, and then sec x dx. And then here I'm going to be left with, how many sec? 8 sec. And here I'm going to be left with, how many tan? 4 tan x. And this one, I take 1 and 1 here, and then integral. So what I'm going to do, I'm going to have to say, hold on. I'm going to have to replace this with tan. Because sec equal to tan plus 1. So I'm going to say this is equal to integral. Instead of say sec, I'm going to say, okay, sec equal to tan plus, okay. Instead of say sec, I say tan plus 1, okay. But sec square, so means I can say this, let me say square, and this is going to be power 4. Still power 8, because I know sec square equal to tan plus 1. So say tan x, tan square x plus 1, and then power 4. And then here tan 4x, and then this is going to be, okay. And this half here, tan x sec x dx. Okay, now let's let, if I let tan equal to u, okay, so I'm going to let u equal to tan x. Differentiate, if I differentiate tan, I get, no, I made a mistake. I apologize, I made a mistake, because now, if I differentiate tan, I get sec square, so wrong substitution. I was supposed to do the other way around. Okay, my apologize. Or if I take sec, and differentiate, and then I get sec tan. Hold on. If I take tan and differentiate, I get sec square x dx, and it's not here. You know what I'm saying? So let me do this. I did other one wrong just a little bit. So go back and see. Okay, cool. Let's look careful. So for that case now, let me say, okay, sorry for that. let me say crazy. Another question, but just okay. So now, let me say you're gonna be laughing at me like, oh come on, that question right there. Okay. It's like come on, I see it. He's always like, okay, cool. So now, let me say just a second. Time is running. Okay. Let me say for the time here, okay, just a second. If I let okay. If okay, let's put everything here in sec for that case. Okay, so this is gonna be sec 9x, and this is gonna be okay. Instead of say tan, we're gonna say sec square minus 1. It's gonna be sec square x minus 1. Okay, but okay, it's like saying this. Okay, let's put okay. Let me go slow. Let's take one tan aside here. Okay, let's put everything in sec, and then okay. Okay. If I say, I appreciate your patience, right? If I say sec, and then if I take, okay, if I differentiate tan, you get sec square x dx. Okay, let's make this 7. Excuse me. Make this 7. Take 2 sec here, sec square x dx, and then and this tan here. Okay, and the tan. Come on, man. Okay, if I take second tan, okay. Easy question. Come on, guys. I appreciate your patience. Just a second, right? I get it done. It come from here. Okay, come from here, man. Okay. It's very easy question. I don't know how I lose this. How I lose sight of it. Okay. Now, if I say sec square, okay. If I say. Let me do question number 7, 8, and then I'll come back. Okay, just a second. Integrate sec. When you integrate sec of a function dx. When you integrate sec of a function of dx, well, I'm thinking, right? When you integrate sec of a function, you get sec of a function. Sec of a function. You get long? When you differentiate sec of a function. This question. It pissed me off. I'm going back and I'm coming back. Okay, you see that it can't distract me even from solving another question, but I'll get it right. Okay, now integrate sec of a function. Integrate sec of a function, you get sec. No. If you integrate, you don't get straight away. If you integrate sec, okay, then I'll come back for that one. Okay. No. Sec is easy. I'll show you now how to solve sec. Let me solve this one. Sec I got it. Or let me show you sec. You see it's a start. Okay. Integrate sec. So what I want to do here, look, I want to do something. I want to say sec tan, sec x plus tan x, and I'll say over sec x plus tan x for a reason, dx. Because I know if I differentiate this, it's going to give me the one on top. So let's say m equal to sec x plus tan x. Okay, when you differentiate, it's going to give, when you differentiate sec, you get sec tan. You get sec what? Sec x tan x. So when you differentiate sec, you get sec tan. Yes, but when you differentiate tan, you get tan. You get sec square. When you differentiate tan, you get sec square. You differentiate tan, you get sec square. Okay, sec one. When you differentiate tan, you get sec square x dx. So now we're gonna have to replace this. You know why? Because look, if you expand it, look, it's gonna be sec square, integral of sec square. And there's going to be plus sec tan. Sec x tan x dx, and then over sec x tan x. Sec x plus tan x. So this is m. So it's like say integral of m, and then this half here equal to dm, which is equal to ln of m. So ln, we know what m. What is our m? M equal to sec x tan x, eh? X plus tan x plus constant. So when you differentiate sec, you get what? Sec tan. You get sec tan equals x squared. Okay, now let's go to the question. Okay, now let's go to that previous question. Sorry, guys. Let me go to the previous question. I want to get done with that one. Is this a question? I don't know why I'm losing sight of it. Okay? I hate this. I hate, cause me, I'm not there. Okay, now let's go to that question now. Say, okay? Okay. If I leave here sec, and then tan. Look, now let me do it like this. So like before now. Let's put everything tan. Okay. So this is going to be, let me take 1 sec and 1 tan. Okay. So tan, okay. Tan x from here and then 1 sec from here. So this is going to be sec power 8 x and this is going to be tan power 4. Tan x power 4. Now dx. Now I'm thinking now, I got to put this in tan. Let. No, it's not let. Meaning, if sec, okay, we know sec square equal to that. Meaning this is going to be sec, okay, let me write here, it's going to be sec power 4, sec square x power 4, which is going to be power 8. So this is going to become, I'll say sec, okay, sec square x power 4. Okay, yep, I got it. So, but I know this one. Okay, let me write slowly. Okay, sec square x power 4, and this is going to be tan 4x, and this is going to be tan x sec x. See, it's coming now, dx. Okay, so now, but I'm going to have to replace because everything must be tan except this one. So sec square x tan square plus 1. So there's going to be integral tan square x plus 1, and here we have a tan, but here it's going to be power 4. You see, power 4. Tan square plus power 4. Because this is only sec square, but we got power 4. And then tan power 4x. But this, okay, and also write tan x sec x dx. So if I let u equal to tan x and the differentiate du is going to be sec, differentiate tan, you get sec square. So I need to let something with sec, so when I differentiate, so this must be sec all of this. Okay, I got it. Okay, easy. So what I'm going to do, look, I'm going to have to let sec and then replace all this with a sec. So this is equal to sec x. So when the differentiation is going to be sec x tan x, which is going to give me what? That. But this I have to replace now with a sec. So for that case, this was fine as a sec. Look, I see. So this fine was as a sec, but this must be sec. I got it, man. It's easy. Don't play with me. Okay. Got it. Okay. So this sec is fine. This must be sec. So it's going to be square. So I'm going to put here 2 and here what? 2. You see what I'm saying? But a tan x square, tan square x, what is tan square x equal to sec square minus 1? It's going to be sec square minus 1. Now look, if we let u equal to sec and then differentiate, okay, see, it's done already. I can do it again if you want, but okay, let me just finish up and then I'll do it again. So you see it's going to be integral, what is the sec? Sec equal to u square times 4, and this is going to be u minus 1, and then this is du because tan sec equal to du. See, I got it. And they can multiply that out. Okay, let me do it for you, and they can understand. So everything here must be tan sec. Okay, cool, I got it. Let me do it again for you. I apologize, guys, they were handling this situation. Okay, now, so we're going to say integral. So I'm going to turn all this stuff to sec because I figure. So sometimes you play around, like left, right. So I'm going to say this is going to be sec. I'm going to leave only one sec. It must come here, sec. 8x. So, and then this is going to be tan what? Square x power 2, which is power 4. And then one sec, I'll take it here. And then one tan, I'll take it there also. You see what I'm saying? So turn this to sec. So we know sec, you know. So say sec Tan square, what is tan square? Tan square equal to sec square minus 1. It's going to be sec minus 1. And this is going to be sec square power x power x. And then this is going to be sec x tan x. Tan x. So I like now tan, okay, let u equal to sec. Because if you differentiate this, it's going to give us what? Sec tan. Sec x tan x dx. So this equal to du. So it's the integral, and this equal to u. So it's going to be u square, and this going to be u square. This going to be u square. Oh, power 4. Yes, power 4. So u square power 4 means this is. Yep, u square power 4 equal to power 8 means. Because it's going to be u square times 4, 2 times 4 equal to 80, u, and then it's going to be u square minus 1 and then power square. And all of this equal to du. So now the question is finished because it's a power of integral. So integral, now I can do straight away. No, you cannot do here first. Okay, this is going to be u. Okay, now let's expand. Okay, this is going to be u power 4 and then minus 2u power 2 plus 1 and then du. Now, this and this is going to be 12. Power 12, but since you integrate, okay, let's just show some people who know. So it's going to be u power multiply 12 du, and then minus 2u. Okay, this is 16. No. This and this is going to be 32. Woo. 32. Oh yeah, 32. 32. No, you add them. Come on, you don't multiply them. This is the 12. The this is going to be 2. U. Okay, that's in there. 10 plus 1, 11. Du, and then we plus integral u power 8. Okay, du. So now let's integrate power of plus 1 is going to be u power 13 over 13 minus 2 u power plus 1 is going to be 12 over 12, and then plus u plus 1 is going to be 9 over 9 plus c. Now we know the value for u. What is the value for u? U equal to sec. So this is equal to sec what? X, but a power 13 over 13 minus, this is going to be 1 over 6. 1 over 6. And this is going to be sec 12x over 12x over 6. This one is just 12x for this 6. Okay, minus, okay, this is going to be sec power 9x over 9, and then we plus plus our c. So we're done. That's how you do. I appreciate your patience. Okay, now we continue. So, question, if we finish all this, it's going to be 8, right? Okay, cool, let's go. Okay, let me go quicker, because we need to go quick with this, okay? Oh my god, okay? Okay, cool, let's go. Okay, now we go to question number, this one we're done already, now we go for this one. 7, 8, integral of sec, let's say 2x dx. So what we're going to do, okay, we're going to do the same game here, okay? So I'm going to introduce here, say integral, but this I think I did already. Yes, I did. You want me to do it again or not? Nah, let's just keep it. But if you want me to do it, I can do. Since it has a 2, okay, let's do it if it has a 2. So I'm going to do the same thing. I'm going to introduce now. But it's the same thing. I just did it. I say I introduce. So I introduce sec x, okay. Introduce sec x plus tan x dx, and the same thing. Top and bottom. Sec x plus tan x. So it's like, look, it's like nothing because this and this is equal to 1. So it's like you need not change anything. So this, let me say, if you multiply that out, it's going to be integral sec square x plus sec tan x, tan x dx, and then over sec x plus tan x dx. So I can let this equal to m. So let u equal to sec x plus tan x du. Okay, this is going to be sec. If you integrate sec, you get sec tan. So sec x tan x, and then this is going to be tan. This is going to be sec square. When you integrate tan, when you differentiate tan, you get sec square. Okay, so this is this. We may say du. So du. Okay, and this is going to be equal to u. So over u, and that's going to give us ln of u equal to ln. We know u. U equals sec x plus tan x. Absolute plus constant. We're done. Now let's go to question number 79. Okay, go to question number 79 right now. Let me see if you're recording. Does it record? Is it recording? Oh yes, it records. Okay, cool. Okay, 79. Okay, sine, integral of sine 2x, and then we got 2 plus cos x dx. Okay, so what we're gonna do now? Okay, I'm gonna break down. So this is the integral of 2 sine. So I take 2. This is double angle 2 sine x cos x. So take 2 out here. Okay, and this is going to be 2 plus cos x dx. So I want to let u equal to the denominator. So let u equal to 2 plus cos x. So du 0, and this is going to give us negative sine x dx. So I can take negative 2 this side. You see what I'm saying? So then I can come and substitute some stuff. Sine x dx equal to negative du means sine, this sine x and cos x. I can flip it actually so you can see clear. Sine x and dx equal to negative du. Or this you see, you can say cos x sine x is acceptable. I can start writing as a cos x so you can see. So sine x cos x equal to negative du. So I'm going to say that question become integral. We have a 2 is negative, right? Negative go out. So this sine x dx equal to negative du. Okay, negative, no, just negative went out, so du. You see what I'm saying? And then, so the problem here, what about the cos? Okay, I'll substitute now. So 2 plus cos x equal to u. This equal to u, but what about this cos? You can get cos equal to u minus 2. Look, cos equal to, if you come, it's going to be u minus 2. So it's going to be u minus 2. Okay, so this is easy because now you're going to say, there's a negative 2 here, right? It's negative 2, yeah. So I say negative 2, I can say u integral of u divided by u, du, minus, there's a 2, you separate, integral of du over u. So what I'm saying means integral of the face of the u, and then 2 also with the u. Or you can write here, so just in case you don't know, 2 over u, and there's a minus. Take 2 out, 2 go back, so now we're going to say this is equal to 1. So equal to negative 2, okay, now when you integrate integral of du, because it's 1, it's like 1 times the du, integral equal to u minus, and this is going to be 2. Okay, this is ln of u. Okay, so now we're going to say this equal to negative u. What is a u? We know our u. U equal to 2 plus cos x. Okay, you know what I'm saying? I don't know I'm writing this. I can just put like this because it's bright. Minus plus 4. Isn't this 4? Isn't this just 2u plus 4, because this is 4, and then ln. So say ln, and then absolute, since there's a ln, we know u. What is a u? You got 2 plus cos of x. Plus cos. Okay, now we go for the next one. The next one is going to be question number 10. Okay, question number 80. So when you finish this, you say in 88, okay? When you finish this question, means question 88. So when you finish this, is going to be question number 88. Okay, now let's go question number 80. So integral of tan, add tan of 4x. If somebody say add tan of 4x, it's same as say integral of tan inverse of 4x, same thing. So don't just guess, How did it come? What happened? So now let's go easy. So this is by parts. So I can say this is 1 and this is U and this is dV. So say let U equal to, because in by part we use this formula. U dV equal to UV minus integral V du. Okay, now U equal to tan inverse. Tan inverse of 4x differentiate du equal to, when you differentiate tan of a function, what you do, you differentiate whatever we have here. Let me write like this. Differentiate and then over 1 plus square of your function. Square of your function, just like that. And then dx, because you differentiate with respect to dx. du equal to, this is going to give us 4, and then it's going to be 1 plus 16x squared dx. Okay? Now you come here, integrate there, because this is u, and then dv equal to dx. So now dv equal to dx. Integrate. V equal to x. Okay. So we got all the. Okay. So now equal. This one, integral u dv, means the one they gave to you. Equal. So I can rewrite this here, but no time wasting. Equal to uv. What is a u? U equal to this times v. So I can start with the x first and then go to tan inverse of 4x. The minus integral v. What is a v? V equal to x. And then multiply by du. What is a d? It's a du. 4 or whatever. So I can take my 4 out and I can write 1 plus 16x squared dx. So this is easy. So what I'm going to do, I can just do, if you want, I can do substitution slowly, but with me, I know the answer, but I can just show you how it's done. Okay. Now with that, you can just let u equal to the denominator, because I know if I differentiate this, I get the one on top. U equal to 1 plus 16x squared. Square, and then if you differentiate this, will give you du equal to, this is going to be 32x dx. X dx means, so divided by 32 divided by 32, this side and this side means 32 is going to come here. So x dx equal to du over 32. So this is going to become this one only here. So this one is going to become, okay, it's going to become integral, okay, x dx equal to du over 32. Du over 32. So I take 32 at the back. Now this is going to be 1 over u. So it's going to become 1 over 32 ln of u plus constant. But I want the value of u. What is the value of u? Equal to 1 plus 16x squared. See? 1 plus 16x squared plus constant. So with me, I was going to do straight away. You know what I was going to do? If I find out, if I differentiate this is x squared, right? Just x squared. It give me x. And then I can just say straight away, okay? This and say, this and this is going to give us 32. So 1 over 32. Differentiate whatever you have here, 32. And they say ln of the denominator. That's the easy way of doing it. But I was just doing it to show you. You see what I'm saying? So now, we know how we got there. Even if I delete it, but I know exactly what the answer which is there. You see? Peace. Thanks a lot. Thanks, Melissa.
My queen, you gon' wait me till Jesus come. Why when I talk, pocket full floss, money, honey, forget about Suzanne.
So since we don't have all the equipment like, you know, cameras and all this stuff, so just use one of the webcam from my computer.